This is a LattePanda3 Delta. This part of the project is to utilize the onboard Arduino Leonardo that's built in on the LattePanda3 for a project that assists with the use of the LattePanda3. There are expansion boards along the edges to access parts of the LattePanda3 that are not normally used for experimentation, things like that. This part is the Arduino section here. So I built a separate breakout board to plug in the headers and wire them down to a bigger terminal board that fits underneath the LattePanda, strapped onto the headers, so it's nice and solid, it won't affect it. And that brings out all the Arduino points to a terminal board so they can be used. Additionally, added another terminal board for some functions that are going to be useful for the project. Okay, so this project, the idea for this Arduino project using the onboard LattePanda3 Delta Arduino is this LattePanda3 is being used as a control station for an amateur radio station. These are the components of that station. There's a transceiver, the power supply, and then a display. The LattePanda is hooked up to the radio itself, so we can control it over the Windows 10 with the interface program. There's also a sound card. This sound card is used for doing the digital transmissions, things like that, via the computer. It's got to transmit, adjust, or receive, adjust, delay, adjust, and also has a push to talk. So that makes it a little bit different. It interfaces directly to the radio. The idea is to enclose all these components, the LattePanda3, USB signaling, the radio, the power supply, and the transceiver, all in one enclosure called a Go box. And then what we would do is it would sit here and we were ready to go out into the field, say for an emergency situation. All we have to do is pick up the Go box and go with it, maybe pack up a couple plugs, and then we'd be ready to go. So if it's an enclosure, we need to have some type of fan control unless it's totally open. So that's what I chose for this project. The enclosure fan control project that I have built for this Arduino that's on board the LattePanda3 consists of a thermistor that's for the outside temperature of the enclosure. There is a thermistor for the inside temperature, and the control scheme monitors both the inside temperature of the enclosure and the out. And here is a fan. Whenever we go real life, it'll be a different size fan based on the size of the enclosure and all the Watts loss calculations. And there is a relay controlling that, and we have the option sometime later on of going to a PWM supply. Right now the fan turns off and on by the relay. It allows me to use 115 volt fans, but if we want to use 12 volt fans, we can go to MOSFET drivers and actually control the speeds. The last component of this is it's got a display screen with LEDs. It's a WS2812 addressable LED bar, 8 LEDs. So they've been assigned functions and statuses, and there's a table here of those functions and the different colors mean different things as far as giving us information about how the control system is running. So that is what we're going to be videoing here is verification and demonstration of those functions of the Arduino doing a fan control for an enclosure with an inside and outside thermistor feedback. We're moving on to demonstrating the functions of the LEDs and the control system itself. We're going to talk about the displays. Right now the outside temperature reads green because we're inside. If it gets below 15 degrees C, it just turns blue to tell you, yeah, it's cold outside. It'll turn red or yellow as it gets hotter outside, just to give you an indication that maybe you ought to think about getting out of the sun or maybe moving to a cooler location. The inside of the enclosure temperature is pretty important, and it's going to be green right now, actually just because the same thing as room temperature. If it gets up to 40 degrees C, it'll turn yellow to give us a flag. It's getting pretty warm inside the enclosure. If it gets to 50 degrees C, it's going to turn red to say we're getting really close to the edge of the equipment's high-end temperature. We ought to be thinking about fixing it or getting it cooled down. The inside temperature minus the outside is actually what controls the fan. If the inside temperature is less than 5 degrees of the outside temperature, it's not going to allow the fan to run, because that gives us opportunity to put warm air into a cooler chamber and have condensation on our equipment. If it gets above 5 degrees C on the inside, then we say, okay, it's doing better, it's defrosted, it's okay to run. But at 15 degrees C of the inside temperature above the outside, then the fan will turn on and turn off and cycle. And the light will still be green. If it gets higher than that, it gets to 30 degrees C difference between the inside and outside, then it'll flag as a red and tell you there is a problem. So you need to check that out. The remote PC operator is a red LED that's not installed yet for software. That's to tell you if somebody's remoted in remotely and controlling your equipment. Now the last 4 LEDs are just the I'm Alive LEDs. It has some LEDs left over, and that's, if we see those change speeds, they should stay this speed, but sometimes you'll see a change if we've done something wrong in the software. So it's just an indication. To do a fast demonstration of the Arduino fan control of this enclosure, even though we don't have an enclosure, I'm going to use a hair dryer to simulate the temperatures outside and prove out the functional chart of how this is going to work. Now, if the outside temperature gets hot, really the fan control doesn't care, because it's more worried about the inside of the box. And it'll just alarm, says, hey, you know, it's hot outside. The other thing is, though, if it does get hot, if these thermistors inside or outside, either short or open, these colors are going to change to have false, because they're going to show as a failure now. So we can demonstrate that too. So right now what we're going to do is heat up the outside and get it to settle down. And the only thing that should happen is we'll get the temperature. So the outside temperature is getting warm the other way. I have a hard time doing it. And it turns red. So we got the hair dryer down. We're going to take that off. And as it cools down, those colors will change back to this, so the outside temperatures back in range again. Okay, it's yellow. That's it right there. It's yellow. And it's going to go green here once it cools. Okay, so the other temperature sensor is right here. So we're going to blow a hair dryer fan's on, so it's doing what it can. And we okay still because the inside temperature minus the outside temperature is still green. Okay. Oh yes, that caught that up. So I'm going to say it's hot. Now it's the inside temperature minus the outside temperature is about hot enough to say. It says, yeah, something, this fan's not cooling it now. So I've moved it, the colors are going back down again. The fan's still running. And it's going to keep running until that thing comes out of the inside temperature, gets out of yellow. So it's green, so the fan's running and the fan is stopped now. Oh, there's my finger. I've done a pretty good job of covering up these thermistors so that they don't get shorted out. Well, I'm going to skip that part. It's already been tested. It says it's a failure mode and the lights behave properly. What I'm going to do is I'm going to open circuit one of the thermistors to demonstrate what happens. So what I did was I removed, there's one of the thermistor leads to simulate an open thermistor. Okay, so you can see that the inside temperature went white, said it has a thermistor failure. The outside temperature is still green. The inside temperature minus the outside also says there's a sensor failure with the thermistor. So on any thermistor failure, we automatically just go ahead and turn the fans on, just in case. This time, I removed a lead from the outside thermistor, which is over here. Pull the lead off the terminal board. And now we have a different set of colors. The outside temperature now is showing white. That says it's got a problem. The inside temperature is showing green. The inside temperature minus the outside is glowing red because it's got a problem. It thinks that the outside is much hotter than the inside. So that's what we've got going on right here. The fan is running on a fan failure, on a thermistor failure. So we've kind of proved out the control is operating like it's supposed to be. And it's really kind of cool that we have a LattePanda that we can apply and put it in an enclosure with other things and program the Arduino to do auxiliary functions, like doing a fan control on the enclosure with thermistors and indicator lights. So this is a really fun little project to do for a ham radio station Go kit.